Alright, in this video we're asked how many 7-digit numbers, or in this question number 6, how many 7-digit numbers can you make that are even, so even numbers, less than 3 million, it can be formed using the digits 1, 2, 2, 3, 5, 5, or 6. Okay, so there's two restrictions here. The first one is that the number must be even. Okay? If a number is even, that means its last digit must be even. We're allowed to choose from these numbers. There's only two even numbers there. There's a 2, there's two 2's, and one 6. So that tells me the last number must be 2 or 6. One of those two things. So we have those two mutually exclusive cases. The second restriction we're given is that it must be less than 3 million. If it's going to be less than 3 million, that tells me something about the first digit. The first digit must be less than 3. If the first digit were 3, we'd have 3 million in something. If it was 5, we'd have 5 million in something, 6 million in something. So the only way for it to be less than 3 million is for us to use either this 1 or the 2. So we have these two mutually exclusive cases. So we're going to have to now count up these cases separately. So actually, we're looking, okay, we have two cases here, two cases here. That's going to lead to 4 cases. Case 1 would be if we had a 1 first, and then let's say a 2 last. Case 2 would be if we had that 1 first, and the 6 last. Case 3 would be if we had now the 2 first, and say the 2 last. And case 4 would be if we had the 2 first, and the 6 last. Okay. So notice, in all these cases, we really only have 5 remaining positions to be filled. So that should tell us we're going to have, if we have 5 remaining positions to be filled, we're going to calculate 5 factorial. But now we're just going to have to worry about how many repeated objects are there in these 5 positions. So if I have 1 and 2, so I'm using the 1 and the 2 in the first and last position, I'm left with a 2, a 3, a 5, a 5, and a 6 to go into these positions. So I have 2 5s, meaning I have to divide by 2 factorial. Okay. So 5 factorial over 2 factorial is 5 times 4 times 3, which is 60. Okay, so case 1, with a 1 first, 2 last, we have 60 possibilities. Case 2, where you have a 1 first and a 6 last. So that tells me I'm using the 1 and the 6, so I'm left with 2 2's, a 3, and 2 5's. So 2 2's, a 3, and 2 5's. Okay. So again, 5 factorial, because there's 5 things being permuted, but there's 2 2's are the same and 2 5's are the same. So I'm dividing by 2 factorial, 2 factorial, which tells me this is 30. In this one, 2 and 2, so I'm using both the 2's, so I'm left with a 1, a 3, a 5, a 5, and a 6. So 1, a 3, a 5, a 5, and a 6. So 5 objects, 2 of them are 5's, so 2 of them are the same. So 5 factorial over 2 factorial, so again that's 60. Last case, 2 first, 6 last, so I'm left with a 1, a 2, a 3, a 5, and a 5. So again, 5 factorial over 2 factorial equals 60. Right, so these are the 4 cases. So now I'm just going to add these cases up. So in total, this would be the rule of sum. Right? We're adding mutually exclusive cases. There are 60 plus 30 plus 60 plus 60 equals 210, 210 even numbers less than 3 million. So there are 210 numbers that fit our given restriction.